All right, we are going to talk about U substitution today. All right, what we've been doing throughout this trimester is when I teach a derivative rule, I try to teach an antiderivative rule along with it, or we at least practice how would you, and think about how would you antiderive if I gave you the derivative, how would you get back to the original function? We just learned the chain rule. So now we're going to work on antideriving the chain rule, undoing the chain rule, which is a concept called U substitution. All right. So one of the problems with this section is there's some notation that's required that's a little bit unfamiliar to you, and then sometimes students struggle to find the inside function, what we're going to call the U. All right. So let's start off with just an example where I think you could probably figure it out if you puzzled over it for a little while. If I gave you the derivative, and I said this is the derivative function right here, f prime of x, could you find f of x? Well, you might be able to think about it and think, all right, well, here's my inside part, right? And there's a 2 out here, so maybe there was a 2 up here in the original function. And this 3 maybe comes from the derivative of the inside, so you could maybe piece together that the original function was something like this. Like that, and then, plus something, plus some constant. And so you can maybe figure that out, right? The only problem is that a derivative would never be left like this, right? It would be left as 2 times 3, which is 6. Okay, and so the question is, if it's not glaringly, I don't want to say obvious, because maybe it's not obvious until you've done enough of them, but if it's not, if things are simplified, if the problem is not as simple as this, because this is one of the simpler U substitution problems, what is a method we can use that will scale to more difficult problems? That's what U substitution is. If you can look at the problem and just figure out what the original function was, then that's fine. But a lot of instances you won't be able to do that. So let's take this same problem and let's apply the U substitution method to it and see what it looks like. So this will be our first example. Remember this notation for right now, that elongated s along with, hold on a second, 3x minus 1 times 3, along with the differential here, dx. You are interpreting this and this dx to mean take the antiderivative, okay? So the method that we're going to use here is we're going to say, all right, well, it's a lot easier to antiderive a simpler function, like x squared. Like I could antiderive x squared, I'd add 1 to the power and divide by the result. Not that big of a deal, okay? So what our goal here with U substitution is to make this thing, this integral is what it's called, but to make it simpler so that we can just apply a simple, more familiar antiderivative rule. So the way I'm going to do that is I'm going to look for an inside function, the function that's inside of another function. And right now, I'm going to notice that that's 3x minus 1. So off to the right here, I'm going to make a note. U is going to be 3x minus 1. And then I'm going to simplify. I'm going to carry this notation, this integral notation, down. So I get 2 times u times 3 dx. Now, the problem that we have now is that we have u's, our function is in terms of u, and our differential here is in terms of x. In the winter, we will talk more about why the differential matters so much. For now, you just need to know that you can't have a function in terms of u and be antideriving in terms of x. Okay? So how do we alleviate that? How do we fix that? Well, we're going to go over here to that little note we made about what u was, and we're going to take the derivative with respect to x of it, of both sides. So d dx of the left, d dx of the right. What I'll get then is du dx is equal to the derivative of 3x minus 1. That's just 3. Okay? And then I'm going to treat this as a fraction and move the dx over to the right. So I'll times those sides by dx. So what I end up with is du is equal to 3 dx. And I notice over here, check it out, I've got 3 dx here that I can make the substitution in. So in place of that, I'm going to put du. Okay, so I'll write another line of work here. So I get 2u du. And this is, you don't really need to put the braces in if you don't want to, but this is just like a problem we dealt with in the previous chapter, where if it's 2u and I say, and you're anti-deriving with respect to u, then you take the antiderivative, you just add 1 to the power, divide by it, and you get your answer. So your final answer then is, not your final answer, sorry, your almost final answer is going to be u squared. You drop the notation because you're actually anti-deriving at that point, plus c. Now, if our function started off in terms of x, then it should end in terms of x as well. So we go back to our scratch work that we made up here. What was u? Well, it was 3x minus 1. So this will just be 3x minus 1 squared plus c. Okay, that's what our original function was. Okay, function whose derivative was this expression right here, right? Now, I understand you could multiply all of this out and make it a simpler problem, simpler antiderivative problem, but again, I try to show you the method on a simple problem so that we can see how it works. All right, let's do a more complicated problem. Still not too bad, but we are going to make it a little bit worse here. So let's try to take the antiderivative of x squared plus 3 to the third power. Oh, shoot. 2x times 2x, okay? So I have x squared plus 3 to the third power times 2x. Again, this one you might actually be able to figure out on your own, but let's, without using u substitution, but for the sake of using the method and practicing it and getting more familiar with it, let's use it, okay? So I look at this, and it looks like x squared plus 3 is the inside function, the inside part. Remember how the chain rule works. Derive the outside, leave the inside alone, times by the derivative of the inside, okay? So what I'm going to do then is, off to the right, I'm going to say, let u equal x squared plus 3, okay, the inside part. Now, I know what's going to happen. If I plug u in here, I'm going to still have this 2x dx. So I'm still going to have x's and dx's in that expression. And everything has to be u for me to take the antiderivative without making a mistake. So over here, I'm going to take the derivative of this with respect to x. And I get this. Du dx is equal to 2x. So this is a good step, but I need to finish it out. I'm going to times both sides by dx. And I get du is equal to 2x dx. All right. So what I should notice then is that I have 2x dx right here. Sweet. I can substitute then du in for 2x dx. So I'm going to do that. I end up with this expression then. U to the third. So I'm plugging that in. Sorry. Chose to make this video during the changing of classes here. So, and then in place of this, I'm going to put du. And this is a much simpler problem to antiderive, right? Because this is a power rule problem. So when I take the antiderivative, I'm going to lose the notation, and I will get 1/4 u to the fourth plus c. But our original was in terms of x. We should end in terms of x. So our final answer then, f of x, is going to equal 1/4 x squared plus 3 to the fourth power plus c. And that's our final answer. And all of these, you can check your answer by taking the derivative. And if you take the derivative and get back the what was up here, then you did it correctly. Okay. All right, here's what I would like you to do. This is an exercise for you. I would like you to just take a second, pause the video, and in all of these, find the u. Okay? And see how you do. A is 4 sine of 5 minus 4x dx. B is e to the 2x minus 1 times 2 dx. And C is, oh boy, 9 times x to the fourth plus x cubed times 4x cubed plus 1 dx. Pause the video, go ahead and see if you can pick out what the u would be, the inside function, and then play the video and see how you did. All right, we're back. Hopefully you paused and tried it. the u on this one will be this 5 minus 4x here. And you can also maybe notice that when you derive 5 minus 4x, you will get 4 dx, which is nice. So u in this one is 5 minus 4x. U in this one is going to be 2x minus 1. Again, you might notice that the derivative of 2x minus 1 is 2 is hanging out over here. And then in this one is probably the hardest of the three, I think, because you've got two things that really could go either way. But if you notice this right here, if you derive that, you will get 4x cubed plus 1, which shows up over here. Okay, so in this one, u should be x to the 4th plus x. Okay, so part of this is just part of the process that is sometimes difficult for students is just getting the u correct. Okay, let's do at least one more here. How are we doing on time? 10, 11 minutes. Okay, we'll do one more. All right. Let's do that first one from part A up here. So in this example, we are going to find the antiderivative of 4 sine of 5 minus 4x dx. Okay. So I already said my u was going to be 5 minus 4x. Now I know if I just plug in u right now in for this, what's going to happen is I will have just u. I will have sine of u and dx, and we have to keep the variables the same, so let's take the derivative. Du dx is equal to negative 4. I'm going to move the dx over to the right, so I get this. Du is equal to negative 4 dx. All right, this is not quite exactly what I have over here, right? I have 4 dx. I don't have negative 4 dx. So to make this match, I'm going to times both sides by negative 1. So I get this. Negative du is equal to 4 dx. And now it matches. So now in place of 4 dx, I'm going to put negative du. So what will that look like? Well, it'll look like this. I'll have negative sine of u du. I usually just put the negative out in front. It's sort of weird to put the negative behind the sign. Okay, so that's my simpler function to take the antiderivative of. So now when I antiderive negative sine, it's just going to be negative cosine of u plus c. All right, negative cosine, and just check, when you derive negative cosine, you will get back, it will be positive sine, or positive cosine, sorry. When you derive cosine, you will get negative sine of u, okay, times the derivative of u, but anyway. It's not as important. So then we need our answer in terms of x. So our final answer is f of x is equal to cosine of 5 minus 4x plus c. Okay. And so again, you can check your answer. With the chain rule, you will get back to the original, I think. And I think that just about does it for u substitution. I've got one more example here, but honestly, I think we've pretty much covered it. I might make a short video of it in case you're still feeling a little bit uncomfortable on how to do u substitution. You might find it worthwhile, but otherwise, that's the meat and potatoes of this lesson. So, of course, let me know if you have questions, but that's all I've got for u substitution for now.